Okay, so let's talk some more about the intermediate value theorem and evaluating limits. Okay, so if you remember in the last video, we talked about the intermediate value theorem, which says that if f of x is a continuous function, on the interval a to b, then for any m between f of a and f of b, there exists c such that c is in between a and b, and if I plug in c into my function, I will get that value. So in graphic form, essentially if I have some function between a and b, so here at a I have f of a, and here at b I have f of b. If I pick any value in between f of a and f of b, let's say right here, m, then I'll find a c in between a and b such that if I plug in c into my function, it equals m. Okay? So this theorem is very useful, and it's often used to prove that functions exist, to prove that functions have roots on a particular interval. So let's do an example, but first let's talk about what a root is. So a root, it's also called a solution, a zero, or an x-intercept. These all mean the same thing. And essentially, a root is all your x values such that when I plug it into my function, I get 0. Okay? So for example, the root of x cubed plus 1, okay, is x cubed plus 1 equals 0. So I want to find the x that makes this true. So x cubed equals negative 1, x equals negative 1. That's my root right there. Okay? So often the intermediate value theorem is used to show that a function has roots on a particular interval. And let's do an example of that. So for example, let's say I have a function f of x equals the 5 times the cube root of x minus 2 minus 4. So this is continuous. And the question is, let's say given f of 2 equals negative 4 and f of 3 equals 1, does f of x have a root between 2, x equals 2, and x equals 3? And so we can use intermediate value theorem to show this. Essentially, I don't know what my function looks like, but I know that at 2, I'm over here at negative 4, and at 3, I'm over here at 1. Okay, so here's 1, negative 4, 2, and 3. So I don't know what my function looks like in between. But what this is asking for is there an x value that makes my f of x equal to 0? So according to the intermediate value theorem, since f of x is continuous, and, okay, f of x equals 0 is between f of 2 and f of 3. So you can see here's f of 2 right here, and here's f of 3, okay? So f of x equals 0 is in between those two values. Then there should be some x. Then, according to the intermediate value theorem, there is some x such that it is between 2 and 3, where f of x equals 0. So using our intermediate value theorem, we know that our f of x is in between f of a and f of b. Therefore, there is some x value that makes f of x happen. Okay. All right, so that's the intermediate value theorem. Now let's talk about evaluating limits. So the simplest way to evaluate a limit is to just find the value of the function at the x that we are approaching. So that's the first method. It's called substitution. So let's say I just give you, find me the limit as x approaches 3 of 3x plus 2. Okay, so if we graph this, okay, x, y, here's 2, and then 1. Okay, so let's just quickly graph the line. We can see that as I approach 3 from the left side, and as I approach 3 from the right side, I'm just going to get the value, the y value at that x. So we can just substitute. 3 times 3 plus 2 is equal to 9 plus 2, which is equal to 11. Okay, so this is the simplest way to solve for a limit. We just simply find the y value at that x value, and that's what we're approaching. As we're approaching that particular x value, that's the value that we're approaching with our function. Okay? Now, sometimes substitution doesn't work, so you have to try other methods. The next best method to try when you've substituted and it did not work is factoring out and simplifying. Okay, so let's do an example of that. Let's say, for example, I ask you to find the limit as x approaches 2 of x squared minus 2x over x squared minus 4. Now, let's try substitution first, see if that works. If I substitute, I will get 2 squared minus 2 times 2 over 2 squared minus 4, which gets me 4 minus 4 over 4 minus 4, which is 0 over 0. Now, 0 over 0 is not a limit. It is a whole, so it doesn't really tell us much. Whenever you see a 0 over 0, that's what's called an indeterminate value. It means we cannot determine, indeterminate, we can't determine what the limit is just by substituting. So we have to try a different method. So when you see terms that you are able to factor out of your function, your best bet is to factor out and simplify before you substitute. So let's try. So the limit as x approaches 2 of x squared minus 2x over x squared minus 4 is equal to the limit as x approaches 2 of x times x minus 2 over x plus 2 times x minus 2. So all I did was factor, okay? This x squared minus 4 can factor out to x plus 2 times x minus 2. Now you can see that you can simplify because we have an x minus 2 on the numerator and an x minus 2 in the denominator. So those two just cancel out. And I'm left with the limit as x approaches 2 of x over x plus 2. Now let's try substituting. So the limit as x approaches 2 of x over x plus 2 is equal to 2 over 2 plus 2, which is 2 over 4, which is equal to 1/2. So as you can see, we now have an idea of what the limit is after we factored and simplified. So in the next video, I'll go over more ways to algebraically evaluate a limit. So you can try some practice problems on your own. Maybe find the limit as x approaches 3 of x squared minus 9 over x minus 3. And you can try the limit as x approaches 1 of 2x squared minus 2 over x minus 1 and see what strategy you need to use in order to find the limits of these functions at these x values.